Okay, this one. All right, so just a quick recap for everyone, especially for the 4 students coming in for the first lesson today. Last week, we took a long time to go through these key concepts. All these are reflection. Now, light got reflection, refraction, and got dispersion. All right, 3 phenomena of light. So reflection is bouncing of light. Refraction is bending of light. So light can bounce off a surface, that's reflection. Light can bend, that is refraction when it goes through different media. And then we have dispersion of light into the 7 rainbow colors. All right, so we were talking about the memory aid here. Just a minute. Let me take my pointer so that it's easier for you to focus. All right, so plane mirror is flat mirror. Convex mirror, all right, you learn convex first, it's easier for you to remember. Convex is a shorter word, concave is a longer word. You learn short word first before you learn long word. It's a sequence, just a memory aid. Now, this is a memory aid. The pink color is a memory aid. There are 4 memory aids here to help you remember things more easily. So for a plain mirror, that is a mirror that you use every morning when you comb your hair. Love, same size. LUV sounds like I love you, that love. All right, but I spell LUV. What does LUV stand for? Laterally inverted upright virtual. So LUV is here. Now, laterally invert means if you raise up your right hand, your mirror image will raise up his left hand. All right, so right hand becomes left hand. That's the meaning of laterally inverted. Upright is the opposite of upside down. Virtual image means you cannot project on a screen. On a screen. Opposite of virtual is real. Real means can be captured on the screen. All right, real image, you can actually see the image on a projection screen. But virtual image, you cannot see the image on a screen. Right? So it'll be the image will be same size as the object. So love same size. Convex mirror is love smaller size. Another word for smaller is diminished. So diminished image means smaller. Concave will be love bigger. All right. So LUV means laterally inverted upright virtual. Bigger image, it also means magnified image. Now there's also a RID, memory aid, RID, real inverted diminished. Diminished means smaller. Inverted, of course, means upside down. Now, how come I have 2 different memory aid for concave mirror? It depends on whether your object is close to the mirror or object is far away from the mirror. So if your object is close to the mirror, your memory aid is love bigger. All right, bigger image. Okay. Then if your object is far from the mirror, like a telescope, all right, you want to see a planet far away, you want to see a planet Mars, then it will be RID, real inverted diminished. Obviously, the image of Mars will be smaller than the size of the real planet Mars. All right, so the pink color are the memory aids. Okay, so remember, love same size, love smaller, love bigger, and then read. All right, so for plain, convex, concave. Convex is a shorter word, concave is a longer word. So convex mirror used for security mirror, side mirror of the car, blind spot mirror. Concave is used for whatever you need, like dental mirror or makeup mirror. Is also used in headlights of the cars. All right, so let's start then. Okay, so that's just a quick recap. Then you will look, those who have just joined today, you can look through the slides on your own because we went through this last week. So today we are going to go straight to the question, this one. All right, so for the 4 students joining us, you won't have this set of worksheet. You will have it in a PowerPoint slide. It will be uploaded for you. All right, now let's start. So for this, right, if it's easy question, I will not take too long to explain. So over here, this is the law of reflection. So angle of incidence is equal to angle of reflection, right? So this is quite straightforward, C. Okay, so they want correct one. Okay, so what it means is if you have a mirror and then use this a normal, you always use dotted line. All right, and it makes a right angle with the mirror. I'll draw a shading like that. So this is the mirror, a plain mirror. All right, then let me use a different color for the light ray. So if the light ray is coming in, it will bounce off this mirror surface and it will, all right, be reflected. So this is called incident ray. It's coming in. All right, so incident ray. And this will be called reflected ray. Okay, then where is the angle of incidence? Okay, let me use a different color. So this one, this angle, always measure the angle from the normal. So this is the angle of incidence. All right, because it is coming in. Then the other angle, this angle, okay, is the angle of reflection. So always measure from the normal. So these two angles must be the same. So if this one is 45 degrees, this will be 45 degrees. All right, so that is what it means. All right, is everybody clear? Any questions so far? So light come in here, bounce off. So incident ray, reflected ray. This angle 45 degrees, this angle also 45 degrees, same angle. All right. So always measure the angle from the normal. Please don't say it's this angle. This angle is wrong. This angle is wrong. It's always measured. The angles are always measured from the normal. Please remember that from the normal. All right, let's move on. So I have a concave mirror used for the headlight. So why do we use a concave mirror for the headlight? Why not use convex mirror? Why not use plane mirror? Why use a concave mirror? Right? Can everybody type into the chat what your answer will be? All right, 5 seconds. Okay, to type. It's okay if you give me the wrong answer. 5, 4, 3, 2. Thank you, LeBron, for the response. The rest? 1. Just try. Why is it that we are using a concave mirror for the front lights of a car? All right. Now, most of you got it right. A few of you got this wrong. All right. Don't worry if you got this wrong. Okay. Now, the answer is I'm a driver. I want to see the road far, far away. I want to see in case any person is suddenly crossing the road. I want to see the road ahead, far, far away. So the light can be reflected off as a parallel beam of light. I need a parallel beam of light so that I can see further away. Right. So let me write for you. So the answer is D. So this is the reason why we use concave mirror for the car headlight. This is the front. All right, the front lights of the car. Because you want to see the road, right? Okay, so I can see. All right, I see the road further away. Right, so that there's more time for me to respond in case I need to emergency brake. All right. So if you got this wrong, it is from this slide that you don't understand. So this is the headlight. We went through this last week. So this is a quick recap. So the front headlights is using concave mirror. All right. So this is the concave mirror. Okay. Think of the concave as the inside of a spoon. All right. If you are holding a spoon, everybody look at me, my image. I'm holding a spoon right now. So this is the inside of a mirror. This is the back of the mirror. All right, so inside of a spoon, inside of a spoon, back of a spoon. Now, inside of a spoon is, can you type in the chat? Inside of a spoon is concave or convex? The one that just my foot. If I'm eating a fish ball, the fish ball will touch the inside of the spoon. All right, so the inside of the spoon that the food is touching. Can you tell me what mirror is this? Is this a concave mirror or convex mirror? All right, thank you, Eldia. Thank you, LeBron. Thank you, Wesley. The rest, can you try concave or convex? All right, one of you got this wrong, no worries. All right, good job, Vidu. All right, the rest, concave mirror or convex mirror for the inside of a spoon, that touches the food. Okay, the answer is concave. All right, concave. Okay, so I'm going to help you with the memory aid. So can you think of the inside of a spoon? Right, inside of a spoon, or some people will think of it as front of the spoon. Or maybe top lah, all right, top of the spoon. All right, where the food is touching. All right, food is touching it. That one inside of a spoon will be concave mirror. Right, not convex. Okay, so if you don't know what is concave mirror today, you hold a spoon and then you touch the inside of the spoon, the part where the food is touching, that is concave. This is how it will curve. This is a concave mirror. The light ray will hit the concave mirror. Then if you turn to the back, the behind, all right, the back of the mirror, that is convex mirror. So let me write back of the spoon. All right, is convex mirror. Okay, so how to remember this? Now, every one of us will have our own memory aid. See which one works for you. Can you think of a food in a cave? All right, maybe you think of food in a cave lah. Okay, I write inverted comma, food in a cave. So imagine there's food in a cave waiting for you. Okay, concave, so cave. All right, and it's touching the food, the spoon. All right, so think of the spoon, the food touching which part? So that is the concave mirror. So everybody remember food in a cave, food in a cave. All right, so imagine you go to a cave, there's nice food waiting for you in the cave. Isn't it nice? All right, nice food waiting for you inside a cave. As you walk into the cave, then you have a nice, delicious food there. All right, so back to here. So for maybe let me write here so that I'm scared you get confused. So this mirror here, this part, hang on, this part, this is concave mirror. Okay, concave mirror. Because I have convex mirror below, I don't want you all to get confused. Okay. So here is concave mirror is inside of a spoon where it touches the food. Convex mirror is back of the spoon. All right. So this is the concave mirror. So imagine this is the inside of a spoon where you put your food inside of the spoon. Then there's a light bulb here. All right. Inside there's light bulb. Inside there's light bulb. This light from the light bulb will hit the concave mirror. All right. So light from this light bulb will hit this mirror. Mirror is this one. This is the concave mirror. After hitting, it will get reflected. After hitting the mirror, it gets reflected. After hitting, it gets reflected. After hitting the concave mirror, it gets reflected. Hit the concave mirror, gets reflected. Do you realize that at the end of the day, I have parallel beam of light? All right. So this parallel beam of light will allow me to see the road far, far away from me. All right. This is a driver. The driver is here. The car is moving this way. The car is moving this way. So the light is a parallel beam of light, which allows me to see further away. Okay. So this is why it's very important to use a concave mirror. All right. So this is a concave mirror. All right. For the headlights of a car. Everybody clear? All right, do not get mixed up with the side mirror. This side mirror, right, is using what? Can you tell me this side mirror is using which mirror? Concave or convex? The side mirror. You know, like you look like the 2 years of a car. Everybody type in the chat. Thank you, LeBron. The rest is opposite, right? Convex mirror. This is the blind spot mirror. All right, so this is the side mirror. Okay, side mirror of the car. One car has 2 side mirror, right? Okay. So do not get mixed up. So don't go and tell me, you must tell me which part of the car you're talking about. If you're talking about the headlights, that's concave mirror, so that we have a parallel beam of light to see the road further away. And then the 2 side mirror, this 2 side mirror is using convex mirror. Right, let me put in red. So this one also another side mirror. All right, everybody very clear the different types of mirrors in a car. All right, so concave mirror for the headlights, convex mirror for the side mirror. The side mirror or the blind spot mirror. Okay, question 3. Now find the angle of Z. Z is this angle. So this is the mirror. Shaded line means mirror. This mirror is placed at 30 degrees from the tabletop. So imagine this is a horizontal tabletop. All right, so this is a tabletop. I put a mirror like that, slanted. So this is the mirror. So let me highlight the mirror. Okay, so this is the mirror. All right, it's a plain mirror, it's a flat mirror. Then this is a light ray. Light ray will come in. This is incident light ray, gets reflected. This is a reflected ray. All right, so incident ray coming in, reflected ray reflected out. Then after that, you draw your normal. Okay, so let me draw my normal, dotted line, dotted line. Okay, so this is the normal. All right, always use dotted line to draw the normal. Don't use full line. Normal and mirror must make a right angle. All right, normal, mirror make a right angle, 90 degrees. All right, 90 degrees from mirror and normal. All right, then can you tell me, someone annotate on my diagram, just one person, tell me where's the angle of incidence? Okay, can you annotate in my diagram, where is my angle of incidence? Let me do, okay, hang on, whoever is annotate, let me draw the normal properly. Okay, All right, so where's the angle of incidence?